Hello everyone, today we will be solving the LeetCode problem today, which is invert the binary tree. In this we will be given a root of the binary tree and we want to invert the tree and return its root, or return basically the address of the root. So what does inverting mean? So let's say they have given us example tree. Let me take a smaller one so make you understand. It just gets a bit more complex, so we can understand it fairly easily using this small example. So let's say you're given any node, you have to swap its left child and right child. That's what inverting means. So inverting a node is just convert this to 3 and a 1. So yeah, that's 3 and 1. And that's what they have did in this bigger example as well. Like they had 4 as their root node, then they the child of 4 is 2 and 7, so we swap 7 and 2 that are their root child. So that's what's happening, and then consecutively we have to call on the child of 2 and 7 as well. So that's the inverting thing. Now if you want to invert any node, there could be 3 cases that could arise. The first case is that the node we are inverting, node to be inverted, has no child, no children, neither left nor right. So let's say you are given just a root node and there is nothing. So what will you invert? Like if it has no children, what are you going to invert? So in this case, no inversion is required. So in this case, we can just return our DFS function. Second case is if our node has only one child, right? So since we are given a binary tree, it is ensured that our node has only 2 children at most. So maybe it will have this, or it will have this, or maybe it will have one and not the other, right? So we know that if it has no child, the pointer is null, and after inverting, what should happen? 4 should come here, this should point to null, and this should come to 1, right? Cool. So it is fairly easy to do. We can just call the swap on the left child and the right child. It doesn't matter, we are just swapping pointers here. We are just swapping pointers, and C++ provides a very good implementation in STL of the swap function. So you can basically swap any data structure, you can swap anything. So here we are just swapping the pointers, which is fairly easy to use. We can just write this swap function and we can pass the addresses of left and right. It's very easy to do. Our third case is the standard case, which I just told you, that our node has 2 children. So that is also fairly simple to handle. We just have to swap the pointers. So let's say we have 4, here we have 1, here we have 3. So we can just swap. We have 4 in the left child of 4 we have 1, and the right child we have 3. So we just want to swap the addresses of left and right. So it comes to as 4, 3 and 1. Now you might ask, why are we swapping the pointers? So your question would be, why swap pointers? Why swapping pointers? You can just swap the values, right? You can just swap the values and that would be enough. Unfortunately, it is not enough. That's why we have to swap pointers, because it is possible that 1 might also have its children, 3 might also have its children, and the children can also have some children, right? So if you're swapping the values, you're not swapping these children. So you have to swap the pointers of left and right. You cannot swap the values. So if you I'm just writing here, swapping values is not correct, right? So that's our basic thing. And why I wrote these three cases is just to make you understand of the edge cases in our recursive function. So these are basically edge cases in our recursive function, edge cases. So we found one standard implementation, that is we want to swap the pointers, and our base case is that if our node has no children, so we cannot swap it. And then there is this general edge case that if our node is just null, it does not have child, it does not have the node itself, so we can't swap anything. So in that case we'll return, and then we can call the DFS on the node of left, and then we can call the DFS on node of right. So this is a very simple recursive function. If you know recursion, it is very easy to understand. And at the end we are just returning node. So we call DFS on node. So I think this problem was fairly easy if you could understand this thing, that we have to swap the pointers, not swap the values. Actually I was doing the same mistake, but I realized that I was doing the same thing. Like you can see, I was swapping not this. I was swapping the values, but then it came on to me that we have to swap the values. I don't know, maybe it might be intuitive to you that we have to swap the pointers itself, but it wasn't to me, so I just made it a point. So yeah, I'll put the solution link in the description if you want to refer to more, and thanks for watching.